Hello students, we will solve today question number 9 of chapter 8 work and energy of SC Verma. So the chapter 9 shows that there is a 250 gram mass which is sliding down an incline of 37 degrees with a uniform speed. So we have seen in the Newton's laws of motion that when the block comes down, it has to come down with an acceleration because there will be a force downwards. But in this case, we have to make sure that this block is not moving with an acceleration. So there is uniform speed by which the block is moving. So the question here is, find the work done against the friction as the block slides through 1 meter. So we have to find the work done against the friction. Okay, so for this kind of things, we'll just keep this thing in mind that whenever there is a triangle, this 37, 53, 90. 37 plus 53 is 90 degrees. So this thing will be helpful in many numericals for you. So what we have to do is, we have to understand that the angle 37, angle 53 and 90 degree in right angle triangle where the angle distribution is something like this, you have to understand that one is 3, one is 4 and one is 5. The hypotenuse will be 3 square plus 4 square under root, that will give you 5. So 3, 4, 5 you have to remember. And again you can just remember it like this: the smaller angle, the opposite to that, the smaller side, that means 3. So this is bigger angle, the opposite to that will be the bigger size, that is 4. So this way you can calculate what is cos 37. So cos 37 will be 4 by 5, that means base by hypotenuse. So cos 53 will be this base by hypotenuse, so 5 by 3 by 5. Similarly sin 53 and cos 53 you can get from this. Alright, so now since it is of uniform speed, we know that the acceleration here is 0. So when we draw the free body diagram, you can see that there is a force acting downwards, that is m into g. There is a force acting along the surface upwards. This is the friction force, the kinetic friction force. Fine, and there is a normal contact force perpendicular to the surface of the incline. So here, since there is no acceleration, the force this direction and the force in this direction. So in this direction, the acceleration is equals to 0. That means it is moving with a uniform velocity. So that also means that in this direction the total force will be 0. That means this force will be equals to this force. So the force in this direction will be equals to mg cos 53 degree. You can see it like this. This is 37 degrees. So at this point it will be 53 degrees. So this is mg. So in this direction it gives you mg cos 53 degrees, right? So this force and the force upwards, that is frictional force, the kinetic friction, both will be equals because there is total force 0 in this direction as the acceleration is 0. So mg cos 53 degrees will be equals to kinetic force. So 250 by 1000 is mass. Since mass is given in grams, we have to calculate it into kgs, into g is 10, into cos 53 as we know is 3 by 5. So this gives you the kinetic friction force will be equals to 3 by 2 newtons, right? So simply we can calculate that what is the work done by the friction force. The work done by the friction force will be given by the force into displacement. So it is already saying that the friction force, what is the work done against the friction as the block slides through 1 meter. So distance displacement is 1 meter. So force into displacement gives you minus 1.5 joules. So now why it is minus 1.5 joules? Because the force is in this direction and the displacement is in this direction. Anyways, we have to remember one thing, that the frictional force, the work done by a friction force will mostly be negative. There are some cases where it can be positive, but we will not deal with those cases now. So the friction force, the work done by friction force will always be negative. So what we see here is that the friction force is coming to be negative here, right? So the work done by the friction force is minus 1.5 joules. So that means the work done against friction will be positive of this. So that will give you 1.5 joules. So the work done against friction is equals to 1.5 joules. Now why we will do this thing is also, there is a reason. because since there is no change in kinetic energy, so we know that total work done is equals to 0. That means work done by the frictional force and work done against the frictional force, they will be equal and opposite. So they will be minus of each other. So that's why our work done against friction force will be equals to 1.5 joules. So that the total work done comes to be 0 since there is no change in kinetic energy. So we know that when there is no change in kinetic energy, the total work done on the system will always be equals to 0. Now this thing you may be seeing that we have solved it without using anything related to work and energy. Alright, so since there is nothing related to work and energy, we'll try to use something related to work and energy and try to solve the same question. So we will be solving it in an alternate way. So we know that if only internal conservative forces are there, total energy, that means the potential energy and the kinetic energy, is conserved. So when only internal forces are there and those forces are conservative, then we know that the total energy will be conserved. But in this case, there is a friction force. So since there is a friction force and we know that friction force is not conservative in nature, the total potential energy plus kinetic energy, that means the total mechanical energy will not be conserved in this force, and this is not a conservative force and is an external force also for the block earth system. Now for considering potential energy, the change in potential energies, we always consider a block and the earth as one system. So for these two bodies, the block and the earth system, this friction force is an external force in this case, and it is also a non-conservative force. So in this case, the total energy will not be conserved. So we know that when the total mechanical energy is not conserved, so there will be some change in the mechanical energy since the forces are not conservative and also there is external force. So we also know that the total work done by the external forces is equals to mechanical energy, change in mechanical energy. So when the external forces are there, that means the energy is not going to be conserved. So whatever the work done, the external force is doing, that will be equals to the change in the mechanical energy of a system. I will give you a simple example. Let's say there is a block kept here. So there is a block kept here on some table. So it is having some amount of a potential energy. Let's say this is ground. So let's say this is ground and this is height h. So we can say that there is a potential energy, the potential energy of this block is mgh. But what I do is I lift this block and put it here. I lift this block by my hand and put it here. So what happens in this case is the potential energy of this block is raised. Now because if this block falls, it will do some work, but if this block falls, it will do greater work because it will hamper a lot of things here down. So this is having more potential energy in it. Now how this potential energy has come? So it has come because I have done some work done in lifting this block from here to here. So for the case of this block and the earth system, I am applying an external force. So my work done as an external force is conserved, it is transferred to this block earth system as potential energy. So this much of potential energy is increased because of the work done by me on this block. So whatever the external agent does a work on this system, that system is getting increase in its mechanical energy due to that work done. So that's what we know, that the total work done by an external by all external forces is equals to the change in mechanical energy. That means the change in final energy minus the initial energy. Now final energy will be equals to the final potential energy plus final kinetic energy minus initial potential energy plus final kinetic energy. Initial kinetic energy. So this gives you this and this. Now since the velocity is uniform, there is no change in kinetic energy. So this will be kinetic energy final will be equals to kinetic energy initially, initial. So totally we see that there is only change in the potential energy. So the whatever the work done is, external work done is, that will be equals to change in potential energy. Now what is the change in potential energy? We see that we have to calculate something for a movement of 1 meters. So we have to see a movement of 1 meters along the incline. This was 37 degrees. So if we see a movement of 1 meter along the incline, what is the movements towards the vertical direction? So that we will get h equals to 1 sine 37 degrees, right? So since this is 1 and this is 37 degrees, this height h will be equals to 1 into sine 37 degrees. That gives you 3 by 5 meters. So we know that the block has vertically moved by 3 by 5 meters. Along the incline it has moved by 1 meters, but vertically it has moved down by 3 by 5 meters. So the change in potential energy is, the potential energy of the block has decreased now. So how much it has decreased? It will be minus mgh. So that will be the change in potential energy here. So that will be equals to minus 250 by 1000 m into g into h. So that gives you a negative change in potential energy, because the at this height the potential energy will be lower than at this height. So this gives you the change in potential energy to be minus 1.5 joules. So here we can see that the total work done external will be equal to change in mechanical energy. That is coming only due to the change in potential energy here, because the change in kinetic energy is 0. So we see that the external work done is equals to work done by the friction force, because we know that here the external agent is only the friction force. There is no other external forces acting. So the external force, the work done will be only due to the work done by the friction. That will be equal to the change in mechanical energy. So whatever the work done friction is doing, that is changing the mechanical energy of the system here. So the mechanical energy is lost by 1.5 joules. So minus 1.5 joules is the work done by the friction. So work done against friction, again the same thing. It will be the negative of what the work done by this friction is. So that comes to be 1.5 joules. So the answer will be 1.5 joules will be the work done against the friction. Okay, so this will be the answer. Okay, thank you students. Please review and give recommendations so that I can upload more videos and get motivated for it. And I will be promising that I will be uploading slowly and steadily most of the crucial questions. For that solution I will be uploading. Okay, thank you.